Hey guys, welcome to Science Class with Mr. Reynolds. Today we're going to talk about Newton's third law of motion. It says for every action there's an equal and opposite reaction. The equal and opposite is the very important part of that. Okay, so whenever we think about equal and opposite reactions, Newton's third law, a lot of times our mind goes towards rockets. Okay, it's funny because in science class, whenever something isn't very difficult, somebody always says, well, it isn't rocket science. Well, this is rocket science. We're actually going to talk a little rocket science here. So in a rocket, what's going on is you've got the propellant, exiting the back, okay? That's the action. The reaction is the rocket moving forward. Now, in early rocket designs, it was more like this, okay, where the propellant just came out and it didn't go very far, it didn't go very high, okay? So somebody got the idea to crimp this, to narrow this down into more of like a nozzle, okay? And that helped a lot. So what I thought I would do is I would call NASA, because one of my former students worked for NASA, and for some reason they didn't return my call. So plan B was for me to go online and buy a couple rockets and go out in the parking lot and set them off. And I saw how expensive they were, so I went with plan C, which is a balloon. Okay, now a balloon and a rocket have very similar principles. Okay, so you've got the propellant inside. Once they get out, okay, this part down here is narrow, like this, so it concentrates the propellant. Okay, so let's try this out. I'm going to let go. The propellant's going to go out. Action. Rocket's going to go that way. Rocket. That's the reaction. Okay, so let's give it a try. 1, 2, 3. Worked like a charm. Mission accomplished. Okay. Now the fact that the rocket went all cattywampus everywhere, that is what happened to early rockets. Von Braun, Goddard, these guys who are pioneers in rocket science, their early rockets would just go anywhere. Until they started to do things like add guidance systems, okay, add fins, things like this to control the flight path of the rocket, okay. So this early, this later improved, okay. Just remember that. Another place that we see this constantly is, think about walking. When you apply force to the ground is pushing back on you. A lot of people don't know that. You might be sitting there right now saying, I didn't know that. So now you know something. So let's imagine this is somebody walking. If they apply 50 newtons of force to the ground is pushing back with 50 newtons of force. If you're in a car or a bicycle, okay, the wheels turning, they're applying pressure to the ground, and the ground is applying pressure, force back, okay, and that's how they're able to move forward. Imagine that you're at a swimming pool, and this swimming pool is in ground, and you want to dive, okay? Usually you get right to the edge and kind of curl your toes over the wall there, and then you push off. Yes, you've pushed off on the wall, but the wall has also pushed on you. So this is kind of neat how we experience Newton's third law of motion all the time. It's awesome. I really think, maybe some of you sitting out there are saying that's actually not awesome, Mr. Reynolds. I think you're using that term wrong. It's sort of like, I guess, when a little kid uses the word biscotti, okay? He thinks he's using the right word, but people around him don't think he is. So let's just go with, this is mildly interesting, okay? That'll be the term. Okay, so mildly interesting, Newton's third law of motion. So I hope you learned something. Thanks for coming, and I'll see you next time.